Since the Angel is a one-man airplane, the devices normally operated by a 3 to 6-man crew must be crammed into the tiny cockpit. This complicated periscope sextant, developed in 6 weeks by Dr. Robert Hills, Jr. of Baird Atomic Incorporated, attaches firmly to the airplane so that the pilot need not turn around in the cockpit. A navigational trainer is used for pilot familiarization. For long-range navigation, the sextant is coupled with the Perkin-Elmer drift sight that doubles in brass as a viewfinder for reconnaissance cameras. By pre-computing star angles or sun angle for any course, a pilot may navigate without resorting to involved calculations. The complete optical system is filled with dry nitrogen to prevent condensation. The primary objective of the Watertown project and development of the Angel herself was to obtain the maximum reconnaissance information possible from any single flight. Hycon Manufacturing Company was selected to build a series of 4 photographic systems to fit the equipment bay of the Angel. The company faced the problem of producing equipment that would operate completely unattended for the full mission of the Angel and bring back negatives of resolution at least 3 times better than the best existing equipment. Hycon's Special Project Group, under the leadership of Vice President William McFadden, drew key personnel with a long background of reconnaissance camera work from other company projects, just as other groups siphoned their most talented people into this program. H.C. Silent, one of the nation's outstanding electronic and photographic engineers, made major contributions to the early stages of the project. He was aboard on the Mount Charleston shuttle crash. Hycon cameras feature lightweight, high-resolution aspheric lens elements, contoured platens to retain the high resolution, and film capacity up to 12,000 feet. First of the reconnaissance installations, the A1, really consists of 4 separate cameras. 3 6-inch wide-angle cartographic cameras are mounted, 1 vertically and 2 at 56 degrees. The A1 gives horizon-to-horizon coverage on 3 9x9-inch negatives. This TriMet installation of cartographic cameras can be used for small-scale mapping of large areas. In conjunction with the TriMet group, a 24-inch rocking mount camera records medium-scale intelligence information on 9x18-inch film. A single photograph from just the vertical cartographic unit will cover a 400 square mile area, while a vertical negative from the 24-inch lens covers a 5x10 mile area. The complete unit, with film enough for a 3,000-mile flight with stereo overlap, weighs only 339 pounds. Each Hycon camera system has image motion compensation to cancel the forward speed of the aircraft and maintain the high resolution of film and lens. The A2 camera configuration consists of 3 24-inch units similar to the large camera of the A1. The center camera is mounted vertically, the others at 37 degrees from the vertical. These photographs were taken by an A2 camera unit over Sacramento, California. Details smaller than 4 feet can be recognized, as demonstrated by these 4 and 10 diameter enlargements. With their 1,800-foot film capacity, the 3 A2 cameras will photograph a strip over 2,000 miles long and 37 miles wide with 55% stereo overlap. One of the most unusual reconnaissance cameras ever to be developed is the B camera system. The B is an entirely new concept in camera design and violates virtually every taboo in the business. In a completely new reconnaissance concept, the lens cone, and mirror of a camera are rotated to any one of 7 positions from vertical to the horizon on either side, covering a path 750 miles wide on a single flight. The B camera can be preset to any one of 4 exposure patterns. It can swing horizon to horizon in 7 exposures, shoot a series of 3 vertical and near vertical pictures, pattern 3 more on a high oblique angle to either side, or be set in a fixed position. In only 12 missions, all the significant intelligence and physical information of the entire United States could be recorded with the overlap needed for stereo evaluation. The B configuration carries a 36-inch lens to cover an 18 by 18-inch format, which portrays a 6.6 miles square of the ground from the vertical. Here is a 10 diameter enlargement taken from 13 miles high, which clips One of the key contributions to the whole program was the development of a completely new aerial film by the Eastman Kodak Company, specifically for the cameras of the Angel. Dr. Cyril Stout and Fordyce Tuttle of the Eastman Kodak Company directed the project. Less than half the thickness of previous film, only 32/10,000ths of an inch, this new film is higher in red sensitivity than most and will cut through more haze. Use of standard aerial film would have reduced flight line coverage by 50%. With this outstanding new Eastman film, reconnaissance photos may be made during all the daylight hours. This thin-based film won't work in just any camera. Only a carefully designed system will guide the film properly. One of the really significant developments in camera design is the drive mechanism to handle this new thin-based film. It was virtually impossible prior to this development to transport aerial film of this thickness with any reliability. The B camera, for instance, transports over 2 miles of film from its 2 cassettes. This requires meticulous film manufacture, careful spooling, and the closest tolerances in film transfer. To keep the center of gravity from moving during flight, one roll at each end of the camera is loaded with up to 6,000 feet of 9.5-inch film, run in both directions with a 1/4-inch gap between the 2 film paths. Thus, the center of balance of the camera is the same, no matter how many exposures have been made. The film moves continually through the camera at a fixed speed. However, like a movie camera, the film behind the lens is held stationary during the instant of exposure, while at the same time, a vacuum holds the film tightly against the contoured platen. To assure rigidity, the rotating portion of the B camera was made of formed thin steel. Originally, a vibration detector was used to trip the shutter at the instant the Angel was most stable. This 3-axis rate detector analyzed all movement and told the camera to fire at the most favorable time. However, the Angel has proven such a stable camera platform that this unit is no longer necessary. The 7 windows of optically flat glass in the B camera hatch are cleaned and window covers installed before flight to protect the glass from dust and condensation. These hatch covers are later jettisoned at altitude. The A1, A2, and B cameras have been designed to bring back general intelligence information, and their shotgun inquiry is meant to cover relatively large areas. Once an area of interest has been found, a follow-up flight is needed with the new C camera system, which gives 5 times the detail of the B camera. This camera is considered the ultimate in photographic equipment for the Angel. With well over 2,000 moving parts, it is undoubtedly the most complicated and versatile piece of reconnaissance equipment ever to be airborne. The C unit has an intricate 180-inch focal length optical system, somewhat like a telescope. Optics of this focal length, crammed into the small equipment bay of the Angel, represent an outstanding technical advancement in the state-of-the-art of lens design and camera construction. Frequently called a folded trombone optical system, where the light goes round and round, the camera has 6 mirrors and a total of 26 lens surfaces that the light strikes before reaching the 13 by 13-inch film plane. This optical system is one of the several basic new lens designs created for the project by Dr. James Baker of Spica. The lenses were produced by Perkin-Elmer, with Dr. R.M. Scott directing all their project activity. Then Hycon built the camera. The front surface mirrors are coated with pure aluminum. The only cleaning permitted is with tiny low-velocity streams of air. The C camera has an independently stabilized mount that can move up to 3 degrees in any direction to cancel movement of the aircraft. In older reconnaissance systems, a good stabilization mechanism would normally exceed the weight of the complete camera. By using a radical new concept in stabilization to save weight, space, and power, the complete C stabilizer accounts for less than 75 of the 550-pound total weight. This transistorized unit uses rate stabilization with recentering between exposures. The captivator of the C orients the camera with the airframe just before each exposure, so that the camera will see the same area appearing in the pilot's viewfinder. The camera is then uncaged for 0.8 of a second so that any minute vibrations are canceled before the shutter is tripped. Such stabilization is required because of the extreme focal length of the C unit. A small control stick in the pilot's compartment is used to pinpoint targets either beneath or to one side of the aircraft. A memory delay unit developed by Perkin-Elmer will permit the pilot to select a target as much as 60 degrees ahead and to one side of the aircraft. When the target is centered in the viewfinder, the pilot presses a button and the camera system does the rest. As the plane passes the target on a straight course, the memory delay unit inclines the mirror to the correct side angle and shoots 2 patterns of 4 pictures each that bracket the target. By tilting the mirror 3.5 degrees on the first set of photos, 4 times the normal stereo effect is obtained. The memory unit can handle 3 preset targets at one time, eliminating the need for the pilot to concentrate on the crosshairs of a viewfinder. In another mode of operation, the C camera can follow the undulations of a river or road and will function automatically with sufficient overlap for stereo evaluation once the correct image motion compensation speed is established. The shutter has a circular disc turning at 500 revolutions per minute. The 8-inch disc has a capping blade rotating with it to uncover the opening in the disc for exposure. Shutter speeds are changed from 1/100th to 1/1000th of a second in flight by an automatic exposure meter. Film drive mechanism of the C camera differs in some detail from the other Hycon units, but in practice the operation is similar. Despite the intricate mechanical and electrical systems in this automatic camera, reliability is approaching 100%. The C camera is encased within a nitrogen-filled envelope inside the equipment bay. Thus, the optics of the system are protected from the condensation of moisture or coating from engine oil. Short film clips are processed at Watertown after each flight to check operation of the complete camera system. Negatives from the C camera system have the inherent detail to tell all about what lies on the surface of the Earth, since the camera pinpoints an area of only 1 square mile from 70,000 feet. Negatives clearly show pedestrians, and detail as small as 4 inches can be recognized. The roll of undeveloped film then goes to Rochester, New York, where Eastman Kodak has set up a photographic laboratory specifically for film from this project. To obtain the maximum reconnaissance information from any one roll of film, this lab can develop negatives exposed at sunrise, midday, and sunset, with exposures varying from 100 to 1, and yet retain the high image clarity necessary for photo interpretation. Here, Eastman is turning back the clock to the 1890s, when box cameras were sold with a roll of film installed, to be later returned to the factory for processing. "You push the button, we do the rest," has been one of the best known of American trade slogans. The Rochester lab does the rest by a unique two-stage developing system in which all film goes through a primary developer, is then dried and inspected by an infrared viewer. Underexposed film is then further processed through one or two additional developments to bring out details exposed at very low light levels. The combination of trained personnel, photographic chemistry, emulsion research, quality control, and specialized machines yield the information from the Angel's flights. The specialized lab equipment required for this painstaking developing process has recently been modified for field use. The Eastman Lab in Rochester is also set up to develop, print, and duplicate film from the 70mm tracker camera that goes along on every flight. The tracker provides a reconnaissance photo record that shows exactly where the Angel has been on its mission. This Perkin-Elmer camera carries 1,000 feet of film and makes a horizon-to-horizon exposure twice each minute. From this record, photo interpreters can pinpoint the aircraft at any point of its flight. A rotating prism with film drawn across a variable width slit make the exposures. A special processing machine for this 70mm film was designed by Eastman and delivers results at 10 feet per minute. A second recorder carried on all flights is part of an S and X band radar monitoring system developed by the Ramo-Woolridge Corporation. It is called System 1 and intercepts signal sources within 350 miles to each side of the Angel. System 1 then records these signals on magnetic tape. The 11.5-pound tape recorder employs a unique coaxial reel structure to minimize both size and weight. It provides a 9.6-hour, 3-track recording on almost 1 1/4 miles of special half-mil Mylar base magnetic tape developed to Ramo-Woolridge specifications. One track records signals received from the right side of the vehicle. A second records those from the left, while the third track records a timing tone and special signals when the cameras in the equipment bay are tripped. The addition of only 2 pounds in weight would have eliminated many engineering problems, but the Angel didn't have 2 pounds to spare. Uniform velocity and tape flutter were controlled by precision machining rather than the use of heavy mechanical filters. The System 1 recorder mounts in a small recess beside the pilot's seat. System 1 antennas are unusually lightweight, metallically coated fiberglass materials and mount near the nose on each side of the aircraft. On one of the early flights from Watertown, System 1 tape indicated that a fighter interceptor had approached the Angel at night with its radar fire control system operating. An immediate investigation was begun to prevent further violation of the prohibited area by unauthorized aircraft. 2 other electronic systems, a long-range navigation package and an automatic radio monitoring system, were developed by Ramo-Woolridge and test-flown in the Angel at Watertown. Simultaneously, a 4th system was under development.